All right, 10.2, finding measures of arcs. In this section, we're going to learn 3 different types of arcs: a minor arc, a major arc, and a semicircle. A minor arc, well, first, an arc is just a part of a circle. So the entire circumference goes all the way around a circle, but an arc is just part of a circle. So if we look at this circle C, we see a central angle. A central angle is when an angle has its vertex on the center. So this angle right here, ACB, so this is angle ACB, has an arc that corresponds with it. It actually has 2 arcs that correspond with it. First, let's talk about the minor arc. So the minor arc. The minor arcs are less than 180 degrees. So here is angle ACB. It is a central angle because its center is, or its vertex is on the center of the circle. This angle opens up to arc AB. It is a minor arc because this arc is less than 180 degrees, so the arc opens up to less than 180 degrees. So this is arc AB. And you note it by 2 where the arc starts and where the arc finishes. And you put a little arc over those 2 endpoints. So the same angle ACB, if I put it over here, angle ACB is also a major arc. So if you think about angle ACB and in bigger than 180 degrees, it opens up in this direction all the way around. So this is the major arc of angle ACB. And it is bigger than 180 degrees, and you always note a major arc by 3. So by 3 letters, where it starts, a point it goes through, and where it ends. And it could go the other way, where it starts, a point it goes through, and where it ends. So this arc, you could call it arc ADB. You could also call it arc DBA. So, and the arc should go all the way across. So this is a major and a minor arc. And same thing with this one. So this arc could also be arc BA. So the central angle ACB opens up in 2 ways, to the minor arc and to the major arc. And the arc, again, is just part of the circle that the angle opens up to, the central angle. So the next part is talks about measuring arcs. The measure of a minor arc is the measure of its central angle. The expression measure of arc AB is read the measure of arc AB. The measure of the entire circle is 360 degrees. So all the way around is 360 degrees. The measure of a major arc is the difference between 360 and the related minor arc. The measure of the semicircle is 180 degrees. So the semicircle is just like when the diameter goes across, that's a semicircle, half the circle. So in this case, again, central angle ACB, there is the minor arc AB, and since the central angle is ACB, that means the minor arc is also 50 degrees since angle ACB is 50 degrees. Which means that the major arc of ADB is the difference between 360 and the minor arc. So 360 minus 50 would be 310 degrees for the major arc of ADB. All right, so that is the major minor arc and finding the values of it. So example 1, find measures of arcs. So first I want to add this in is finding out whether it's a major, a minor, or a semicircle. So in this first one, I notice there's 2 letters. Automatically that tells me this is going to be a minor arc. I know this is a minor arc because only minor arcs are denoted by 2 letters, where it starts and where it ends. So if I come over here to my circle, it starts at D and ends at E. So I look on my circle and I'm looking for the arc. So I look for D and go on the arc to E. Since the central angle DCE opens up at 117 degrees, that means the arc from D to E is also 117 degrees. Now this is something I also like to look at ahead of time too. So I like to find the pieces of the other arcs as well. So I can tell that D goes through the center, or DF goes through the center and ends at F, which means DF is a diameter. So then if I want to find this arc, then I could take 180, which is half of a circle, minus 117 to give me that this is going to be 63 degrees. This angle right here. This entire right is a semicircle. It is a diameter. So this entire arc right here is 180 degrees. So I like to find the other pieces. It just helps things go faster when you're finding the arcs. So this is DFE. Now this is either going to be a major arc or a semicircle. Semicircles are also noted with 3 letters as well as major arcs. So let's look at it. D, it starts at D, goes through F, and ends at E. So you can't go the other way because you can't go D through F this way. So you can't go to the left of D. So you have to go D through F to E. So that means that I have to go from D to F to E. This arc goes from here all the way around. That means it's 180 plus 63, which means it is this arc from D through F to E is 243 degrees. And it's bigger than 180 degrees, so it is also a major arc. All right, 3 letters tells me it's either going to be a major arc or a semicircle. So I'm going to look at it. So this one, and let me erase this last arc. All right, it starts at D, and then it goes in the direction through E. So that means I'm going to the left. D, E, ends at F. That is half the circle. That means it's a semicircle. So it's a semicircle, and it is 180 degrees. So again, semicircles and major arcs are both denoted by 3 letters. Minor arcs are only denoted by 2. This right here, there's only 2 letters, tells me automatically this is a minor arc. EF. And by figuring it out earlier, I figured out that 180, the diameter, minus the known 117 degrees gives me that 63 degree arc. It starts at E and ends at F. This part of the circle of the outer piece is only 63 degrees. Okay, so that's example 1. On the back. Arc addition, very similar to segment addition, to angle addition. It's arc addition. So we are adding the arcs around here. So the measure of an arc formed by 2 adjacent arcs, adjacent means next to, so arc AC is adjacent to arc AB, adjacent, is the sum of the measures of the 2 arcs. So basically, the measure of arc ABC, ABC is equal to the measure of arc AB plus, so AB plus arc BC. So I added AB plus BC gives me the measure of ABC. That's arc addition. So we'll use that in the next example. So you join a new bank and divide your money several ways. In the circle graph at the right, find the indicated measures. Well, it's actually to the below, but all right. So first, I noticed there are 2 letters. It's a minor arc. So let's see, arc AC. So it starts at A and then goes to C. So let's see, I'm going to add 105 degrees plus 60 degrees. So that means the measure of arc AC, I'm going to take arc AD plus DC, and that's going to be 165 degrees. So it was 105 plus 60. All right, the next one, 3 letters. That could either be a major arc or a semicircle, but I don't see any diameters here, so we won't have any semicircles, which means it is going to be a major arc, which means it will be bigger than 180 degrees. So arc A, B, C. It starts at A and it goes through B, so which means I have to go from A, I have to go to the right, not to the left, because I have to go through B and end at C. So I'm going to add 55 plus 140, and it's just those 2 arcs right there, which means the measure of arc ABC is 195 degrees. All right, let's erase this arc to get ready for the next one. And again, this is a major arc because it's bigger than 90 degrees. I mean, 180 degrees. Oh, minor arc, 2 letters. And minor arc BD starts at B and then goes to D. Okay, now this is a good one. So notice that it starts at B, and I could go to B to D this way or B to D this way. This is a good question because A to C, this first one over here, I could have gone A to C or A to C, but it's a minor arc. It has to be less than 180 degrees. It's a minor arc. BD is a minor arc. It has to be less than 180 degrees. So for minor arcs, it's when you start, you say, okay, if I go right to D, is that going to be bigger than 180 degrees or less than 180 degrees? Well, if I go to the right, that'll be bigger. That means I have to go left to D. That's less than 180 degrees. So the minor arc would be 55 plus 105. So that would be 160 degrees. Make sure you match it if it's less than 180 with the correct minor arc. So BDC, it's going to be a major arc, should be bigger than 180 degrees. Okay, DBC, start at D, go in the direction of B, and then end at C. So I'm going all the way around. So it includes everything except for this 60-degree arc, which is nice. So for this one, I can take the entire circle and just subtract that 60-degree arc. So this major arc is going to be 300 degrees. All right, last example. And then I have a few extra examples to go over too. Identify congruent arcs. Tell whether the given arcs are congruent. Explain why or why not. So there's 2 things you have to look for. The first, they have to, for 2 arcs to be congruent, they have to have congruent radiuses, or radii. And the second thing, you have to know for sure that they have congruent central angles.
What did you do?
Okay, so you have to know the radiuses are congruent and that the central angles are congruent. If you know for sure both of those are true, then yes, you can say the arcs are congruent. All right, BD, arc BD, and arc EC. Arc BD, so this arc, and arc EC, this arc. Okay, so the radiuses is the same because they are all, it's in the same circle. We know all of those radiuses are the same. This central angle opens up to the same. And they both add this unknown piece. So it's 75 plus this unknown. And this is 75 plus this unknown. And they both have the same radius. So yes, those arcs are congruent because we know they have the same radius. And the central angle plus the unknown, central angle plus the unknown is exactly the same. Okay, so the next one. Arc AB. So this arc. And arc CD, this arc. All right, so first thing is, we know that they both have the same central angle. They both open up to 80 degrees, but they do not have the same radius. Notice that the inner circle has a smaller radius than the outer circle has a bigger radius. So no, the radiuses are not the same. Radius not congruent. All right, FG and HJ. So we see that the radiuses are congruent. So whatever this radius is, it has the same radius on this circle since they have congruent arcs. And they both have a 90-degree central angle. So yes, it fits that they both have congruent radiuses and congruent central angles. All right, so a little bit more on finding arc measures. Whoa, let me zoom out a little bit. I think you can see that. Okay, all right. So I'm going to do an extra example on finding major, minor, and arc measures. So here I have AC is a diameter. Oops, that should say BE. And BE. AC and BE are diameters. So I'm going to first find out whether these are major or semicircles, or major, minor, or semicircle, and then also find the arc measure. All right, so first ED. Oh, I always like to start off by first finding all the measures. So even if you're only given part of it, I like to go in and find out the measures of the rest of them. So since I know that EB or BE is a diameter, that means that all three of these angles should add up to 180 degrees. So I can take 180 minus 70 minus 45, and that'll give me this angle right here, 65. And then I can also say, well, since this AC and BE are diameters, that means they crisscross. That means these two angles are vertical angles. So since they're vertical angles, I know that this right here is 45 degrees. And AC is a diameter, which means this arc right here is 180 degrees. So 180 minus this 45 gives me the remaining angle up here of 135. I always like to go in before I start answering what the arc measures is and figure out what they all are, and then it makes it a lot easier going through. So first, the first one I'm going to do is ED. Right away I see that it has two letters, minor arc. I'm just going to shorten it, min for minor. And ED, if I look, let's see, ED. And I wouldn't go E all the way around to D, because then that would be bigger than 180 degrees. So since it's minor, it's less than 180. So that means it's from E to D, the short way, 70 degrees. AE, right here. I figured it out already, so it takes a little less time to go through that. So I wouldn't go A all the way around to E. It would just be from here, less than 180 degrees. This is a minor since two letters, and it's 45 degrees. AEB, that means it's either a semicircle or a major arc. So A, and this one tells me I have to go left because I have to go through E first, then to get to B. So A, E, B. That means I'm going to take A, E, B, these four sections, and add them together. So 45 plus 70 plus 65 plus 45 gives me 225 degrees for that arc, that major arc. ABC. So start at A. I have to go in the direction through B, so I have to go to the right to C. This is a semicircle, also denoted by 3 letters. So this is a semi, and it is 180 degrees. ADE. So A, I have to go through D. So that means I'm not going through here because I have to end at E. So that means I have to go right and then to E. So it's everything except for this 45-degree arc. So then 360 minus that 45-degree arc is the easiest way to get to that one. So again, this is a major arc. 360 minus 45 is 315 degrees. Arc AB, only 2 letters, tells me right away that's a minor arc. And AB. So I wouldn't go all the way around. That would be bigger than 180 degrees. So from right here, that's 135 degrees. CBA. I start from C, go to B, and end at A. That is a semicircle. That is 180 degrees. And finally, the last one, DC. DC is right here. It's a minor arc, less than 180 degrees. So it only makes sense to go right here at that 65-degree arc instead of all the way around from D to C. So that was just a little extra example for finding arcs with central angles. Angles with their vertex on the center of the angle. Central angles and their corresponding arcs have the same exact measure.